Let's learn how to define sine theta, cosine theta, and tangent theta. Let's take a line in first quadrant. First quadrant means this quadrant, right? It should be between 0 and 90 degrees. So if we draw a line which makes angle theta with the x-axis, now let's see how we can find sine theta, cosine theta, and tangent theta for this angle. So draw a line onto the x-axis straight down so that this is 90 degrees. It's not perfect, but this is 90. And let's take the distance from this end of the line to the right angle. This side as A, the length is A, and this side the length is B, right? And this side is C, right? So for this angle theta, the side A is called the adjacent angle, right? Sorry, the adjacent side. So A is the adjacent side, right? Because this is close to the angle theta. Why can't we call this as adjacent? Because this is hypotenuse, right? Because this makes a clean right angle triangle. Oops. Right? This makes a clean right angle triangle. So this is your hypotenuse. So C should be hypotenuse, right? And that's why we call this as adjacent side, and this is hypotenuse. And what about B? B is quite right opposite to the angle theta, so this is called opposite side. Sorry, I was saying angle. It's side, opposite side. So this is your adjacent side, this is your opposite side, and this is your hypotenuse. What if the angle theta is here? Then this would be your adjacent side and this would be your opposite side. Okay, then you will change. Alright, now let's see how to define sine, cosine, and tangent. So for this angle, the sine of theta, or sine of this angle here, is given by the length of opposite side. I'll just abbreviate as opposite side, over the length of hypotenuse. Okay, so sine theta is defined by opposite over hypotenuse. Okay, how about cosine theta? Let's write it cos theta. Cos theta is defined by adjacent side length over hypotenuse. Okay, so this is given by adjacent side by hypotenuse. Remember, the adjacent side should always be the side next to the angle theta, not the hypotenuse but the other side. Tan theta or tangent theta is given by opposite side length over adjacent. So there is no hypotenuse in here, it's just opposite over adjacent. Okay, what is this here? What is opposite side length? This is B. What is the length of the hypotenuse? This is C, right? And cos theta, adjacent or hypotenuse. Adjacent is A, the length is A, and hypotenuse is C. What about here? Opposite or adjacent? How much is opposite side length? B. How much is adjacent side length? A. B over A. Okay. Now, if this is a right angle triangle, if you know this side as A, this side as B, can you find the hypotenuse? Yes. How? Pythagoras theorem, right? What does it state? If A is the base, B is the height of the right angle triangle, your hypotenuse C is C square equal to A square plus B square, or your C is given by root over A square plus B square, square root over A square plus B square. That is from the Pythagoras theorem, right? So now this would be opposite side b over what is c? A square plus b square, square root of that. Now about cosine, adjacent side a over c, a square plus b square. How about tangent? There is no hypotenuse in tangent, so don't worry about it. So it's just b over a. So these are very important formulas in trigonometry, especially the formulas here. Very, very critical. So once again recall, sine theta is opposite over hypotenuse, okay? Cos theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. Now if I change the angle here, if I take this angle as say alpha or something, now if I ask you what is sine alpha, I'm not asking what is sine theta, I'm asking what is sine alpha, right? So to find sine alpha, you know that it's opposite or adjacent or hypotenuse. So the opposite is this? No, it's not this, because this is the opposite side for this angle. But for alpha, it's a different story. The opposite side is this. So this is not opposite now. This is the opposite for alpha. And this will be the adjacent for alpha, for this angle alpha. How about hypotenuse? Hypotenuse is the same. No matter what you define alpha or which angle you take, the alpha or theta, the hypotenuse is the same. So now your sine alpha would be, the definition is the same, opposite or hypotenuse, but your opposite side is now for your alpha is a or hypotenuse is c, or you can substitute c here, right? This is sine alpha. Now you see the difference. Before you got b or c, now you got a or c just by changing the angle, right? So you got to be very careful which angle you're talking about. Is this angle or this angle? And then the first step would be is to name your opposite and adjacent sides, and then these formulas here. Okay, now let's go over some more examples on sine, cosine, and tan.